Hi guys, welcome to today's lesson. So we're going to start looking at the concept of areas. So this is the first lesson of 3 parts where we're looking at different techniques that you're going to use for calculating areas. First of all, let's try and look at a starter question. We're being asked here to find the perimeter of this garden. So you've got these lengths around the outside. And then you're going to calculate the cost of a fence that's going to go around that garden. So I'm going to ask you to pause your videos now, have a go at this question, and then I'll go through the solutions afterwards. So the first thing that you're going to do, so we're looking at this question, it's asking us to find the perimeter of the garden. Remember, the perimeter just means the length around the outside of the shape. So I've put this question in because I noticed that some of you in the work that you submitted earlier in the week were including one of the measurements that was going across the shape. That measurement is not included in the perimeter. Remember, the perimeter, I described it as you have to imagine you were an ant and you're starting and you're walking around the edge of the shape. So only those lengths that you're passing should be included. You're not going to pass along this length if you're walking around the outside of the shape. So in this case, you're going to add up 20 plus 24 plus 25 plus 18, which gives you 87 meters. Now the second part of the question asks you to think about a fence that's going to go up around the outside edge. So if you're going to put a fence all the way around the outside and you know that the fence is going to cost you £5 per meter, what is the final cost of that fence? Now we know the perimeter of that shape, we know it's 87 meters, and we know that per meter of fencing it's going to cost us £5. And so the final cost is going to be 87 meters multiplied by £5. We're going to get £435. Okay, well done if you got that right. We're going to now move on to the learning intentions. So for this lesson, as I mentioned, we're going to be looking at finding the area of shapes, and we're going to do that by counting up boxes. We're also going to just quickly have a look at what area is, and we're going to look at how we can estimate the area of a shape by seeing roughly how many squares it fills up. Let's move on to some notes. So the first thing, can you please write this sentence into your notes? So the area of a shape can be defined as the amount of space it takes up. The area of a shape can be defined as the amount of space it takes up. If you think of a square that's 1 centimetre by 1 centimetre, we can say it has an area of 1 square centimetre. So this square here, if each of these lengths was 1 centimetre, we could say that total area of the shape, the amount of space it takes up, is equal to 1 square centimetre. 1 cm with the 2 at the top must be read as 1 square centimetre. And square centimetres is a measure of area. So let's look at an example of how we're going to use these facts to calculate the total area of a shape. We'll look at a simple example first. So we're saying here that this small red square here is the same as 1 squared centimetre, 1 square centimetre. So to find the area of this shape on the left-hand side, all I'm going to do is count up how many squares there are. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So we're going to say this is 8 squared centimetres. So this is really important. When you're writing areas, I don't want to just see the number 8. That's wrong. You're not going to do that. What you're going to do is make sure that you've always got this unit, something centimetres squared at the end. It might not always be squared centimetres, it might be squared metres or squared kilometres, depending on the size of the area that you're looking at. Now let's look at a more complex shape. Here, it's the same process. You're going to, again, just count up the number of squares that you see. So we know that 1 square here is equal to 1 squared centimetre. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 squared centimetres. That's the area. So we're going to now look at something called compound shapes. So compound shapes are shapes that are made up of more than one type of shape. So compound just means mixing together or blending together different things. So as I've got on the right hand side, I've got a key that tells me that 1 square is equal to 1 squared centimetre, and anything that's sort of a triangular shape that's half of a square is equal to half of a squared centimetre. So in order to find the total area, I'm just going to add up, first of all, the number of full squares. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to write 9 squared centimeters. The next thing I'm going to do, I'm going to count up how many triangles there are. There's 1, 2, 3, 4. So I've got 4 times a half squared centimeters, which is equal to 2 squared centimeters. So total area is equal to the 9 plus the 2 gives me 11 squared centimeters. And our final example that we're going to look at, now we're going to look at estimating areas. So the way that we do this is, first of all, again, looking at the key on the right hand side, we see that one of these squares that we've got here on this grid is equal to 1 squared centimetre. And what we're going to do is we're going to only count the squares where basically inside that shape, more than half of the shape crosses over that square. So in this case here, we see that this whole square is pretty much covered by that shape. So that bit counts as 1. This shape here, again, is mostly covered. So that counts another 1. This is mostly covered as here. This one, however, this shape here is not mostly covered. So I want to see at least half of the shape is covered. So I'm actually not going to count that at all. This shape here, more than half of the shape is covered. So I'm going to count that as 1 square. This one here I'm going to count as 1 square. This one down here I'm not going to count because it's less than half. This one here is half. That one is more than half. That one there is more than half, and that one there is more than half. So let's count up how many squares I've coloured in. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to say the area is roughly equal to, notice how I've got these squiggly lines, not straight lines, squiggly lines, is roughly equal to 9 squared centimetres. Well done for following that lesson. What I'm going to ask you to do now, I've set you a worksheet, so I'm going to again ask you to complete that in your jotters. Make sure you include all your workings, so you write everything down, including everything that you're typing into a calculator if you need to type anything into a calculator. Make sure you take a picture of the work that you've done and upload that to me on Google Classroom or Show My Homework. Guys, again, thank you for joining today's lesson, and I hope you have a great day.